First thing with this one is to make sure we understand exactly what we're doing, because if we don't get that right, we stand no chance of getting it out. We have the parabola, and we have a straight line going through the origin, and we want the area between 0 and 5, the area between the functions, to be as small as possible. Hopefully you see that if I did a completely different linear function, then I could end up with a truly massive area between the linear function and the parabola, and we don't. We want the smallest possible red area. So that diagram is the first thing. Then it's optimization. It's the smallest possible area, so we're minimizing. So I want to get an area function, differentiate it and set it equal to 0. It's pretty well as simple as that, although we need to get the area function. Area. Clearly there's an area between the two functions and we've got a point of intersection. So y equals x squared. The linear function is the green function. A linear function, mx plus c. If it goes to the origin, we've got no c. So let's find the point of intersection by solving simultaneously. And then x squared so x equals 0 or m. So clearly that's a point of intersection at 0. So this point of intersection must be m. Okay, let's get back to this area function. We've got two areas, one to the left and one to the right of the point of intersection. So to the left, it's going to be the integral from 0 to m of, now the linear function is on top, so it's top minus bottom. And the area of the right-hand side, the parabola is on top. And we're going from m to 5. That's pretty well, we don't really need the diagram now. We're just solving for m here. We're wanting the m that will give us the linear function. So even though it's tech active, you just can't you can't use nsolve with that thing there. You can't differentiate and integrate. It's all a little bit too disconnected. So we're going to need to do some manual integration. I might need a few lines here. Okay. That's going to be mx squared on 2 minus x cubed on 3, 0 to m, x cubed on 3 minus m from m to 5. Clearly I haven't given myself enough room there, so let's just keep going. I need to put the m in first, so that's going to be m cubed on 2 minus m cubed on 3. That's your first bit of that integral. And then I'm going to put the 0 in, so that next one is just going to be 0. I like that one. And then I've got to put this 5 in. So 5 cubed is minus 25 m on 2 minus the next one. I'm going to have to put the m in. M cubed on 3. Excellent. just squeezed that in. A half minus a third is a sixth. Let's just put that M next. This thing here is minus a sixth, so minus minus, which changes that, so it's a like term. So our area will be M cubed on 3 minus. You can see why it's tech active, because otherwise we're going to spend all of our time doing stuff that we don't want to. Okay, so there's our area. So A dash and set it equal to 0, so I guess we can just n solve that, d dx. Set that equal to 0, and we will get m equals plus or minus 5 root 2 on 2. Clearly the plus or minus, because it could be out that side, because of symmetry, and in the context of this domain restriction, we will want m equal just the positive. So let's just get rid of that. 5 root 2 on 2. Okay, that was a little bit easy after we worked out what we needed to do. Good job.